So I am going to take the derivative here of what's inside the parentheses and do the product rule. So I've got f of x times g prime of x plus g of x times f prime of x. That's the product rule for the first part. And then the second part, I have -6 times f prime of x. And the second part of that would be 0 because I'm taking the derivative of -6. Okay, so let me get on my little calculus soapbox here. There were times when I was grading the tests where it would be frustrating because people were losing points for stuff that they know how to do. Okay, so what I'm saying is don't skip steps. Don't skip steps. Okay, you have plenty of time. All right, focus on what you know and pick up the points. They asked me to evaluate this at 3, plug in 3. Okay, that way I'm not going to make a careless mistake when I'm looking back up here and switch f of 3 or f prime of 3 or something like that. Plug it in. Show your work. All right. So now I'm going to evaluate this. F of 3 is -1. G prime of 3 is 2. G of 3 is 1. And F prime of 3 is 5. And then I've got -6 times 5. Okay, so we have -2 plus 5 minus 30. So my answer here is -27. Okay, on this one, I'm going to do the quotient rule. I have g of x divided by f of x, and they asked me to take the derivative. Okay, so low d high minus high d low over low squared. So I've got f g prime minus g f prime over f squared. And then I am going to plug in those values at 3. F of 3 is -1. G prime of 3 is 2. F prime of 3 is 5. And then F of 3 is -1. So I've got -1 squared, which makes it +1. So I have -7 over 1. So my final answer here is -7. Questions on either one of those two? I see these types of problems a lot on the AP exam, especially like the next one where they give you the two functions and ask you to do something, and then you have a chart with the values. All right, so let's take a look at that. Suppose functions f of x and g of x and their derivatives have the following values. Evaluate the derivative of. Okay, so I'm going to take the derivative here. I've got 9 times f prime of x. And then the second part is 0 because of the derivative of 9. What is the derivative of g of 2x? It's g prime. Bring down the 2x. Then I multiply by 2. Now I'm going to plug in the values and evaluate. So I've got 9 f prime of 0 plus g prime of 0 times 2. And don't make a silly little mistake where like f prime of 0, g prime of 0 are not 0, right? They give me a chart over here and they tell me what they are. So go over there and look. And let's see, we've got 9 times f prime of 0, and f prime of 0 is -2. And then g prime of 0 is 5. So I've got negative 18 plus 10, which is negative 8. All right. Well, how can I rewrite the square root of f of x? To the 1/2. So I've got f of x raised to the 1/2, and then they ask me to, again, take the derivative. So I'm going to do the chain rule. 1/2 comes up front, f of x comes down, subtract 1 from the exponent, and then multiply by the derivative of what's inside there. So I'm going to multiply this by f prime of x. Okay. So now we plug in 2. Everybody okay?
Yeah, but what?
Because I have f of x raised to the 1/2 power. All right. So now I'm going to plug in 2. I've got 1/2. F of 2 to the negative 1/2, and then times f prime of 2. All I did was plug in 2. And now I'm going to go to the chart. And f of 2 is 4. Okay, so that's going to give me 1/2, 4 raised to the negative 1/2 times f prime of 2. And f prime of 2 is pi. So what is 4 raised to the negative 1/2? It's 1 over the square root of 4, which is 1/2. So I've got 1/2 times 1/2 times pi. So this is pi over 4. Why don't you do the next one for me, please? It's f of g of x. Check with your neighbor there to see how he or she is doing. So you should get to that point. G of 2 is 2. So we have f prime of 2 times g prime of 2. F prime of 2 is pi. G prime of 2 is negative 1. Therefore, we end up with the final answer of negative pi. Okay. All right, one more here before we go to the second page. So let's look at this. I have the integral from 0 to 8 of f prime of 1 over 4x dx. What is my antiderivative of f prime of x? It's just f of x, but it's not that by itself. It can't be, because if I take the derivative of this, I don't get that, what's in the integrand back. I need to divide the 1/4 or flip it and multiply. So there has to be a 4 out front there. Okay, now I'm going to evaluate it from 0 to 8. So I plug in 8, I've got 4 f of 2 minus 4 f of 0. F of 2 is, I think it's 4, isn't it? Yes, so that gives me 16. F of 0, is that 1? Yes. So that gives me 16 minus 4 for a grand total of 12. All right, let's stretch a little bit.
I'm so tired. For some Adderall.
All right. So this next one is like one that we just did, except instead of giving us a table with the values, they give us a graph. And it says let R of X equal F of G of X, and we want to find R prime of 1. All right, so here we go. R prime of X is going to be F prime G of X times G prime of X. It's my composite function derivative. And then I'm going to plug in 1. So that gives me F prime G of 1 times G prime of 1. So now to get these values, I'm going to look at the graph. And I work from the inside out. G of 1, make sure you get the right function, right? It's the top one. So G of 1 is 4. And then G prime of 1 is 0 because I'm looking at the slope of the line at 1 and it's horizontal. So I've got F prime of 4 times 0. So this has to be 0. So try the next one for me. If h of x is x, f of x plus g, 3x minus 2, find h prime of 1.
Oh.
So my first step is on the board there. And then I'm going to plug in 1. Okay. So G prime of 1 we found earlier, it was a horizontal line, so it has a slope of 0. So that's going to go away because G prime of 1 is 0. F prime of 1 is going to be the slope of the F equation at 1, and that is -1. Plus F of 1 is just the value, the Y value when X is 1, and that's 1. So my final answer here is 0. All right, I have one more example to do, and I see this question fairly often on the AP exam, and the number of people that miss it is very high. Although, if you remember a couple of things, it's really not that difficult. So let's take a look. Example 4 says, let f be a differentiable function such that f of 3 is 15, f of 6 is 3, f prime of 3 is -8, and f prime of 6 is -2. The function g is differentiable, and g of x is equal to the inverse of f of x. No eye rolling. This is not hard. If you remember one thing, okay, this is the key to the question. F and g are inverses of each other, and we are trying to find the value of g prime of 3. So if f of x and g of x are inverses of each other, that means the composite of f of g of x is equal to what?
X of X.
It is equal to x. Why? Because they are inverses. That is the definition of an inverse. Okay, it also works the other way around. G composite f of x is also equal to x. Okay, so if you remember this right here, everything else you can generate. What am I looking for? G prime of 3. So I need to take the derivative. So I've got f prime, g of x comes down, times g prime of x. And the derivative of x is 1. Okay, what's the value of x? I know that because that's what I'm asked to find the value of. So I'm going to plug in 3. For x, I've got f prime g of 3 times g prime of 3 equals 1. So now I'm going to be looking to solve this for g prime of 3. So I need to figure out what f prime of g of 3 is. And I know that g of 3 is equal to what? How do we know it's 6? You're correct. Because f of x and g of x are inverses of each other, therefore the x and the y values switch. Okay, this, the f of 3 there, that is a distractor. That's how. All right, f of 6 is 3, therefore g of 3 is equal to 6. Okay, so that is going to give me f prime of 6, whoops, times g prime of 3 equals 1. And f prime of 6, they give me that, it's -2. Therefore, g prime of 3 equals -1/2, solving for g prime of 3. This is the key though, this right here. We get that and we can generate everything else. So take a look at the next problem, last one here. And see if you can work that out. It says let f be the function defined by f of x is equal to 2x plus e to the x. If g of x is equal to the inverse of f of x for all x and the point 0,1 is on the graph of f, what is the value of g prime of 1? We got it. First step is on the
I know that.
second step is on the board.
That's where I am, Mr. Brown.
Okay, so Jacob, what is the value of x?
1.
So third step is on the board.
Oh my gosh.
So what is g of 1?
Nobody.
Zero.
F of x, Rachel.
Right, and they are inverses of each other.
Oh, so it's
Therefore,
zero. Oh.
g of 1 has to be 0. It has to be 0 because f and g are inverses of each other. And they give me a point. Okay, 0, 1 is on the graph of f. So like when you're reading the question, that should trigger something in your brain. Why did they give me that point? Okay, they have to if I'm going to solve this problem. All right, so now I need to find f prime of 0. And here they don't exactly tell me what it is, but I have an equation for f of x. It's 2x plus e to the x. So I need to find f prime. Derivative of 2x plus e to the x is 2 plus e to the x. And then I want to evaluate it at 0. So f prime of 0 is equal to 2 plus e to the 0, and e to the 0 is 1. Therefore, f prime of 0 is equal to 3. And then I solve for g prime of 1 by dividing. And I get 1/3.
So would there be like a second way to figure this out? I'm not saying that I would use it, but is there like another